Hi everyone. So in this video, we are going to see and learn how to solve this exercise 2. So now we have a plane wave propagating through a mediums, okay, and this is the property of the mediums. Okay, so the question didn't tell us what is the what type of medium is this, right? They give us the dielectric properties. Okay, so this plane wave has an electric field of this. Okay, electric field equations. So you have to determine the phase constants, the loss tangents, the wave impedance, okay, which is the intrinsic impedance, right? The wave velocity and the equations of the magnetic field. Okay, so let us have a guess. What kind of medium is this? Okay, remember we have four mediums, right? We have lossless. Okay, we have lossy, and we have a free space, and we have a conductor. Okay, and let us look at the electric field formulas. Okay, so electric field, you have an amplitude of 0.5 and you have an exponent terms, right? Exponent term which is 1 over 3 z, right? So sine, okay, then power 8t, okay, minus beta and z and x directions. Okay, so I think you see these terms, right? What does this term mean? Okay, this term is telling you that the amplitude of 0.5 will reduce gradually, okay, as it passes through the medium slowly, okay, slowly and slowly. Okay, so this shows that this plane wave is not propagating in lossless, right? If lossless, this won't happen. Okay, for lossless and free space, the amplitude will maintain throughout the whole distance. Okay, so it means that it is not lossless and it is not free space. Okay, in this case, so this plane wave is propagating in the lossy mediums. Okay, lossy mediums, right? And one more thing you can see over here is, okay, you can find out from the equation is that the alpha is equals to 1 over 3. Okay, it's not negative 1 over 3. You must remember. Okay, the alpha is 1 over 3. You don't include the negative. Okay, it is negative z, okay, and negative z here because, okay, because the wave, okay, the electromagnetic wave is propagating in the positive z directions. Okay, so that's why you see negative x z here. Okay, and what else we can get? Okay, we know the angular frequency is 10 power 8 and the electric field, okay, is pointing in the x directions. Right, so this is the informations that we can get from the equations, okay, from the electric field equations. Okay, now let's look at the first one, calculating the phase constants. Phase constant, right? Phase constants. Okay, so how to calculate the phase constant? Okay, what is the formula for phase constants? Okay, I have write down these formulas in my previous video, or you can refer to your notes, okay, under the sections of lossy mediums. Okay, so this is the formulas to calculate the phase constants. Okay, you have 1 plus, right, okay, and then plus 1, okay, plus 1. Let's see, okay, whether we can apply these formulas, right? Do we know the omega? Yes, we know the omega. Do we know the mu and also epsilon? Yes, I know, right? They have been provided, right? Do I know the sigma, which is the conductivity? No, right? the questions didn't tell us what is the value of the sigma. Okay, so we cannot use this formula directly, but we have to apply some formulas, okay, which is the attenuation formulas, in order to simplify the calculations for the phase constants. Okay, so attenuation constant has been provided by the questions, right? It has been provided by the questions, and it says that it is this is the formulas for the attenuation constants. Minus 1, right? And according to the questions, it is 1 over 3. Okay, it's 1 over 3. Okay, so you can compare these two equations. Okay, so you can actually make use the formula and relationship over here, okay, to find the beta. How to do it? Now imagine I create another parameters, okay, a variable that is a, and this a is representing 1 plus sigma over omega square and square root. Okay, I just create another variable. Why? Because I want to make my calculation easier. So it means that my beta will be equals to omega. Okay, a plus 1, right? A plus 1. I have simplified it, a plus 1. Okay, and my alpha is equals to omega a minus 1, right? And the value is 1 over 3. Okay, now let's find the a. Okay, let's find the a so that I could replace the a here. Okay, find a. Okay, so how to find the a? Replace the value that you know. Okay, for example, the omega is 10 power 8. Okay, and the mu. Okay, here I want you to take note on the mu. Okay, which is this. Okay, remember the mu is equals to mu r multiply with the mu naught. Okay, so mu r, okay, is the relative permeability, and it has been given by the questions, while the mu naught is the value, okay, the permeability value of free space. You can get this value from a calculator. Okay, so same applies on the epsilon. It is equals to epsilon r multiply epsilon naught. So epsilon r is the relative permeability, okay, which is equals to 8. And the epsilon naught is the permittivity of free space. You can get it from a calculator. Okay, so now I will replace the value here. So it's 2 mu naught, right? 8 epsilon naught, okay, divide with 2, and then a minus 1 equals to 1 over 3. Okay, so the first step is I'm going to move this to the right side. Right, so I'm going to divide it. So over here, this part is going to be 2 mu naught at epsilon naught over 2 a minus 1. Okay, so it's going to be 1 over 3 divide 10 power 8. Okay, 10 power 8. So if I want to remove my square root, so I have to square the left side and also the right side together, because I want to remove the square root. Okay, so over here I can cancel this, right? Okay, I can cancel this. So I left this mu naught, okay, epsilon naught, okay, I put the 8 in front, so I have a minus 1. Okay, so let's try to calculate this. Okay, you get 1.11 times 10 power negative 17. Okay, and now you want to find a minus 1. So you are going to take this 1.11 times 10 power negative 17 divide with 8 mu naught and epsilon naught. Okay? Right. So it is equals to 0.125. Okay, so my A is 1.125. Okay, so I get my A now. Okay, so I'm going to replace my A over here to be A in the equations of beta to calculate the phase constants. Okay, so it's equals to omega so I have A plus 1 now. Okay, A plus 1, so this is 10 power 8 and this is 2 mu naught add epsilon naught divide 2. Okay, and replace the A here. Plus 1. Okay, plus 1. Okay, so try to calculate this. Okay, so it's equals to 1.375 radians per meter. Okay, right, so this is your beta, the phase constant. Okay, we go for the second one, the loss tangents. Okay, remember what is loss tangent? We talked about this loss tangent, okay, in our previous exercise, loss tangents. Okay, when the questions give us the information of the intrinsic impedance. Okay, because the loss tangent is equals to this sigma over omega and epsilon. Right, so this is our loss tangents. Okay, so we can get these loss tangents by referring to the formulas of our A, you see? This is our A, right? Okay, loss tangent is over here. Okay, so let's try find out what is the loss tangents. Okay, so A equals to 1 plus sigma over omega epsilon square and square root. So from our calculations, we know the A is 1.125. Okay, so let's try figure out what is our loss tangents. So I will square the right side, okay, in order to remove my square root. Okay, so at the same time, I have to square my left side as well. Okay, so when you square it, it becomes 1.26. So over here, it becomes this. Right. So next, okay, I'm going to move this to the left side. And this one to the right side. So this becomes negative 0.26. So I can cancel both together. Okay. So this will be equals to the square root 0.26 okay, you square root 0.26, you get 0.51. Okay, you get 0.51. Okay, so this is your loss tangent. Okay, your loss tangents. Next, let's find the third one. This question C, a wave impedance. How to calculate the wave impedance? Right. Okay, wave impedance, which is the intrinsic impedance. Okay, the eta. Okay, so there are two ways for you to do it. Okay, first is by using the formula. Okay, so this is the formulas. So another way is, since we already know the loss tangents, right? Okay, so we already know what is the angle. So we could simplify our calculations by referring to this. Okay, right. So we already know the value here, so we can get what is the theta. And for the magnitude, okay, we can apply this formula. Okay, or we want to calculate using this way, but this also means that we have to calculate the sigma. Okay, so it depends on what you want to use. So in this case, it will be easier if we apply this. Okay, so we are going to solve by using this method. Okay, so I will write down the magnitude. Okay, the magnitude of the intrinsic impedance is equals to this. Right. Okay. Okay, and then here you have 1/4. Okay, you have 1/4. So over here you have 2 mu naught divide 8 epsilon naught. Okay, replace the value into it. Okay, so this, we get the value, right? So this is the value of our A. No, it's not A, but A squared. Right, it's this one. Right, so I will use 1.26 power 1/4. Okay, so we can do the calculations. So the value is 177.79. Okay, so this is the magnitude of the intrinsic impedance. And for the angle, okay, we have to apply this formula. Okay, so based on the loss tangent that we have calculated just now, which is 0.51, 0.51. Okay, so we can find the arc tangents. So the arc tangents of 0.51 is equals to 27.02. Okay, and this is equals to divide with 2. So you have 13.51. Oh, sorry, I think I have to use the radians. I think it's okay. So I will use degree. Okay. Okay, so this is the angle. Okay, so you have, when you have to write down all of them together, okay, it will be equals to 177.79, and the angle is 13.51. Okay, so this is the wave impedance or intrinsic impedance. Okay. Next, we look at questions wave velocity. Where do we see this wave velocity? Okay, So we see this wave velocity. Where is it? Over here. Okay, so this is the wave velocity. Okay, so we are going to calculate using this formula. Okay, so for D is equals to omega over beta. Okay, so the omega has been given and the beta is 1.375, right? Okay, and the value is 72.73 mega meter per second. Okay, so this is the wave velocity. Right, last one. Okay, last one of this question is the H field formulas. It's the magnetic field formulas. Okay, so for magnetic field formula, we can just generally write it down. Okay, so this is equals to your amplitude, right? Amplitude. And if you consider the attenuation constants here, right? So we have sine 10 power 8 t minus 1.375 z. So this is the beta, and my h, okay, is we need to determine the directions. Okay, right. So now let's determine the directions of the h by using these formulas. Okay, so the electric field is in the x directions. Okay, magnetic field, we know ideas, and the k is positive z directions. Okay, so our h will be equals to y directions. Okay, y directions. Okay, so the x, how do I refer the x? How do I know it's x? So you have to look at the formulas here. Okay, so the electric field is in the x directions. Okay, that's why. Okay, that's why I fill out with x here. And next, we are going to talk about the amplitude. Right, so the electric field amplitude over the magnetic field amplitude will be equals to intrinsic impedance. Okay, so the amplitude of the electric field is 0.5 according to the questions. And we just calculate the intrinsic impedance is 177.79, right? Okay, 79. And the angle is 13.51. Okay, so the magnetic field is equals to 0.5 divide 177.79. Okay, which is equals to 2.81 milli. All right, milli. Okay, and if you want to consider the angle, all right, maybe I should put it in this way. It will be easier for you to understand why. So it will be 0.5. Okay, the angle is 0. Okay, for the electric field, and 177.79. Okay, 13.51. Okay, so this will give me 2.81 milli, right? And for the angle, 0 minus 13.51. Minus because it is divide, so you get negative 13.51 degree. Okay, so if you want to write it as radian, so you can convert it. So 13 times pi over 180, okay, is negative 0.23 radian. Okay, 0.23 radians. Okay, so you can replace it here. And you can replace here. This is Y, right? So over here is 2.81 milli. Okay, 2.81 milliampere per meter, right? And don't forget the angle. So I can put the angle here is a minus 0.23. Right, angle, I put it here. And the directions of the magnetic field is this. Okay, so these will be the equations, okay, of your magnetic field. Okay, of your magnetic field.